So there are two types of methods in order to allocate the memory. So that is static allocation of a memory as well as dynamic allocation of a memory. When I am allocating some memory space during its compilation or before the execution of a program, that kind of memory allocation is nothing but what? Static allocation of a memory. Delete operator is used to deallocate the memory space. Hello everyone, I welcome you all to the next session on pointer. So now let me have a recap on the previous session. In previous session, I have discussed regarding pointer arithmetic. What are the arithmetic operations that pointer can be performed, or what are the arithmetic operator that I can use with a pointer. So what are the operator that I have? So plus and minus, that is increment operator, decrement operator, and I can use addition and subtraction operator. So those are the arithmetic operations that I can perform with pointer, and these are the arithmetic operator which I can apply to the pointer. After that, what are the operations that I can perform with the pointers and what are the operations that cannot be performed on the pointer that we discussed in the previous session. After that, I have discussed the relationship between pointers and arrays. So pointers and arrays, in that it will going to point to the base address. So the pointer will going to hold the address of a first element of an array, so that from that first element I can store the value up to the last elements. So based on the size, it will going to store. Array of pointer. So what is this arrays of pointer? It is nothing but it is a collection of addresses. After that, pointers and string. What is the relationship between the pointer and string? So string is nothing but it is a collection of a character or a stream of character that will be terminated by making use of \0. That represents the end of a string. So how can I use pointer variable in order to work with string? So that was the thing that I have discussed in the previous session. After that, pointers and structures. How can I access the address of the structure variable by making use of this pointer? So that was the thing that I have discussed in the previous session. So coming to the recap, we had a discussion regarding all of these topics. Then what are the today's topic? So in this session, I am going to discuss how pointer can be used as a function parameter. How pointer can be used as a function, argument or a parameter, and memory allocation. So what are the memory allocation of a pointer? There I have two types. It could be either static allocation or a dynamic allocation that I am going to discuss in today's session. After that, at last, so I am going to give you some of the difference between the static allocation of memory as well as the dynamic allocation of the memory. Let me get into the today's session. The first topic is pointer as function parameters. So what is this? Pointer is nothing but what? That is a variable that will going to hold the address of another variable. Can I use this pointer as a parameter or as an argument? Yes, we can use pointer as a argument or a parameter. So now we'll see how can I use that in my program. So before getting into this one, you have to remember what you mean by function and what you mean by parameter or an argument. So functions are nothing but a set of statement which is mainly used to perform a particular task. That is nothing but function. So what I am going to send within the parenthesis, that is arguments are a parameter that includes the variable which is helps to perform a particular task. That is nothing but arguments are a parameter. Then how to define the function? Then I have to follow the syntax like, first I need to specify the data type, then function name. Along with that, if there any parameters or argument is required, then I must specify within that parenthesis. So if you look into this example, here void is a return type. Void is a return type. Then what is the function name? Function name is swap. I am using the name of a function as swap because here I have three variables n and temp. I am going to copy the content or I am going to swap the content of m to n and n to m with the help of temporary variable. That is what I am doing inside the calculation part. Here I have two variables. So which kind of variable it is? pointer variables. How can I say this as a pointer variable? Because here I have a star symbol that represents that this is a pointer variable. So what is the usage of pointer variable? That will going to hold the addresses of another variable. It will going to hold the address of another variable. If you see here, it will going to hold the address of num1 and num2. The addresses of num1 and num2 will be held by the star m, that is pointer variable m as well as pointer variable n. So in this way, I can send a pointer variable as an parameter or as an argument to the function. It will going to hold the addresses of a variable. So what are the variables I am using? Ampersand num1 that represent address of num1 and address of num2. This will be held by star m, that is pointer operator along with the name of a pointer, that is m pointer and n pointer. So this will going to hold the addresses of this num1 as well as the num2. So this is the way in order to use a pointer as an argument or a parameter. It will going to hold the reference. Am I sending the whole copy of the object here? No, I am just sending the address. So it will be more efficient than pass by value method. So here I am using pass by reference because I am not sending the content. I am just sending the address to the function so that it will be more efficient. So this is how I am supposed to take a pointer as a function, argument or a parameter. Let me move on to the next topic, that is memory allocation of a pointer. For example, pointer is also a variable. If you want to declare any variable, at that time what will going to happen when you are declaring any of the variable, at that time particular type of or particular memory will be allocated to particular variable. So that will be based on the data type that you are going to take. For example, here if I have float x, so if I am using this in the sense what? How many bytes of memory allocated? That I want you to comment on the comment section. So here I am going to take, or if I am declaring some variables in the sense, at that time the memory will be allocated based on the data type that I am going to take. If I am using char data type, at that time 1 byte of memory will be allocated. If I am using int, so with the 32 bit, it will going to take 4 bytes of memory. So for example, int a in the sense 4 bytes of memory will be allocated to the variable called a. Then how can I allocate the memory for a pointer variable? So what are the methods that I have in order to allocate some memory space for the pointer variable? So there are two types of methods in order to allocate the memory. So that is static allocation of a memory as well as dynamic allocation of a memory. So what are the two methods that I have in order to allocate the memory? So static allocation of a memory as well as dynamic allocation of a memory. So we'll see the static allocation of a memory. So when I am declaring some variables in the sense based on the data type of that variable, compiler will going to allocate some memory space. So compiler will going to allocate some memory space based on that data type. So if I am allocating the memory before the execution of a program or at the time of compilation, that kind of memory allocation will be known as static allocation of a memory. So here you have to remember one thing, static in the sense it will going to be happen at the time of compilation. That means it will be takes place before the execution of a program. That is nothing but what? Static allocation of a memory. If you see here, static allocation refers to process of allocating the memory during the compilation. So when I am allocating the memory, I am allocating the memory at the time of its compilation. So we have to compile, then we have to check if there are any errors or not. Then only we can run the program, right? So when I am allocating some memory space during its compilation or before the execution of a program, that kind of memory allocation is nothing but what? Static allocation of a memory. Here, for example, int a. So what I am doing? I am declaring one variable called a. Then how many bytes of memory will be allocated? 4 bytes of memory will be allocated. So that will be based on the data type that I am using. So I am using int here. So it will going to allocate 4 bytes of memory. 4 bytes of memory will be allocated for the variable called A. So when it will be allocated? Before the execution of a program or at the time of its compilation. So this is regarding static allocation of a memory. Now we'll see what do you mean by dynamic allocation of a memory. It is just a contrast to the static. So static allocation will take place before the execution of a program, but dynamic allocation of a memory takes place during the execution of a program. So static in the sense at the time of its compilation. When I am compiling the program, at that time only it will going to allocate some memory space to a variable which is based on the data type. So when I am using this dynamic allocation type of memory, at the time this will going to happen during the execution of a program or at its runtime. So that is nothing but what? Dynamic allocation of a memory. So what it refers? It refers to the allocation of a memory that will be takes place during the execution of a program. That is nothing but what? At the time of runtime. So that static is compile time execution. This dynamic is runtime execution. So memory space, whatever the memory space that I am going to allocate is not static. That is not fixed. If I want to allocate more space at its time of execution or at the time of running of a program, then also I can allocate some memory space. So that the memory allocation space or which is the memory space allocated, that is not fixed in the static allocation of a memory. Then how can I allocate the memory dynamically? So with the help of new and delete keywords or with the help of new and delete operator, I can allocate and deallocate the memory space dynamically. So we'll see now what do you mean by new operator and what do you mean by delete operator. So for example, new operator is mainly used to allocate the memory space and delete operator is used to deallocate the memory space. So here you have to remember one thing, allocate in the sense it will going to give the memory space. It will going to give the memory space. So deallocate or delete in the sense it will going to deallocate the memory which is already allocated by making use of this new operator. So what are the two operators that I am going to work with dynamic allocation of a memory? There I have two types, that is new and delete. So new is nothing but that will going to allocate some memory space during the runtime or execution of a program. So delete keyword is mainly used to or delete operator is used to deallocate the memory space which is already allocated by making use of new operator. So we'll see how this new operator will going to work. So what we can do, we can allocate storage for a variable. So here I am going to allocate some storage or a memory for the variable while the program is running. So while the program is running in the sense what? At the time of its execution, I am going to allocate some memory space by making use of this new operator. By making use of this new operator, I can allocate some memory space to the variable. Then how can I allocate this memory space? Here I have a syntax. So what I am doing? I am declaring one pointer variable. What is the name of a pointer? That is P number. How can I say this P number as a pointer variable? Because here I have a star. I have a star that represents I am declaring or I am declaring this pointer variable. So data type is int. And how can I allocate the memory dynamically by making use of this new keyword? We'll see now. First now I have to take the pointer variable is equal to and new keyword or a new operator and I must specify the data type for this P number. I must specify the data type for this P number. So what it means? I am allocating the memory space dynamically by making the use of new keyword to the P number variable of the data type integer. Okay, so what I am doing? I am declaring one pointer variable. After that, I am allocating the memory space dynamically to that pointer variable by making use of this new operator. At last, you have to specify what must be the data type of the pointer variable. So let me take one more example. Here I have int star x. So what it represents? I'm declaring one pointer variable. Can I allocate the memory space dynamically to this pointer variable? Yes. How to do that? X is equal to, I have to take a new keyword. So in order to allocate the memory space dynamically, I have to take the new keyword. And what is the data type of this pointer variable? That is int. I need to take this data type as a int. So what it means here? I am creating or I am allocating some memory space for the pointer variable, that is x. With the help of this new operator, I am allocating the memory space dynamically to the pointer variable called x, which is of the data type integer. So this is how allocation of the memory takes place at the time of its running or at the time of program execution. So now we'll see how delete operator will going to work. And you have to concentrate on these two things. New and delete operator is important for your examination. So coming to the delete operator. So delete operator is mainly used to deallocate. So it is mainly used to deallocate or destroy the variable space. So whatever the space or a memory that I have allocated to particular variable with the help of new keyword. So by making use of this delete keyword or a delete operator, I can destroy or I can deallocate the memory space of a particular variable. So that is the usage of this delete operator. When it will be takes place? It will be takes place during the program execution or at the time of its program execution or at the time of runtime. So that means it will going to destroy or deallocate the memory space of a variable dynamically. So here you can see that. So this delete operator mainly used to destroy the variable space which has been created. So with the help of new operator. So by making use of the new operator, I am going to allocate some memory space. But by making use of this delete operator, I can deallocate the memory space dynamically. That means at the time of program execution. So we'll see how can I use this delete operator in order to deallocate the memory space. So here delete is a keyword or an operator and I have to take pointer variable name and I must specify the pointer variable name. So if you see back to this previous slide, here what I did, I have taken one pointer variable. I have taken one pointer variable and I have allocated some memory space dynamically to that pointer variable. In this delete operator, I am going to deallocate the memory space which is allocated for that pointer variable. If you consider the previous example, here I have a pointer variable called x. Then how can I deallocate the memory space of that x pointer variable? For that I have to take delete x. Here no need to specify the pointer variable. So already we have allocated a memory space to that pointer variable with a new keyword. But when I want to deallocate the memory space, at that time I have to use a keyword called delete along with pointer name or pointer variable name. If you see the previous example, I can deallocate the memory space of this x pointer variable with the help of this delete keyword along with name of that variable. So this is how delete operator will going to free the memory space dynamically. Free the array memory. So I am going to allocate or I am going to create some memory space for the array. Then how to destroy the memory space which is allocated for the array? For that I need to specify the delete keyword and I must specify the size of the array along with array pointer or array name. So in this way I can delete or I can free the array memory space dynamically. Then how can I delete a structure? So in order to delete the structure, I need to specify the delete keyword and a structure. So with the help of this syntax, I can deallocate the memory space which is allocated for the variables by making use of new keyword. So here you have to concentrate how to use the new operator along with how to use the delete operator. So we'll move on to the next topic, that is difference between static allocation of memory as well as the dynamic allocation of a memory. So you have to consider one thing, if it is static then memory allocation will going to take place at the time of compilation. If I am using dynamic allocation of memory, in that allocation of memory will be takes place during the runtime or when the program is executing. So that you have to consider. Now we'll see some of the differences between the static allocation of memory as well as the dynamic allocation of a memory. And here you have to remember one thing, it is important for 3-mark question. What are the differences between static as well as the dynamic memory allocation? So coming to the static memory allocation, what is the first point that you have to remember? So memory space is allocated before the execution of a program. So when the memory will be allocated with the help of this static memory, this will be takes place before the execution of a program. Then what about this dynamic allocation? That will be takes place during the execution of a program. So it will be takes place during the execution. So it will going to happen at the time of compilation, and dynamic allocation of memory will going to happen at the time of execution of a program or at a runtime. So that you have to remember. So memory space allocated is fixed. When I am going to declare a variable with the help of this static memory allocation, whatever the memory that I am going to allocate based on that data type will remain constant or will be fixed. So with the help of this static memory allocation method, I am going to allocate some memory to the variable. Whatever I am going to allocate, that memory space will remain fixed in the static memory allocation. But that will be the not case in dynamic allocation of a memory, because memory space allocated is not fixed here. That will be in the dynamic allocation of memory. Whatever the memory I am going to allocate, that is not fixed. If I want to have some more memory, then I can allocate some memory with the help of new keyword. That will not be the case in static memory allocation. So more memory space is required. Why more memory space is required in static allocation of memory? Because it will going to take place at the time of compilation. So at the time of compilation, it will going to allocate some memory space. For that, it will require more memory. So coming to the dynamic allocation of memory, here I require less memory space than the static allocation of a memory. But what will be the reason? Here I am going to allocate the memory at the time of its running or at the time of execution of a program, so that it will require less memory than the static. So memory allocation will be from the stack area. So how the memory allocation will going to happen? It will going to happen with the help of stack area. But coming to this dynamic memory allocation, it will going to happen with heap area. So stack area, from that I am going to allocate some memory space by making use of this static memory allocation method. I am going to take some of the memory space from the heap area in order to allocate the memory dynamically. So coming to the next point, variables remain permanently allocated because that is static by nature. So when I am declaring, at that time the variables will remain fixed and constant throughout the program. But coming to this dynamic allocation, variables allocated will going to take place dynamically. So if I want to have one more variable at the time of its running or at the program execution time, then also I can take the variables. But that will be the not case in this static allocation of a memory. So what is the next point? It will be implemented using stacks and heaps. So these two are the data structures I am going to discuss in the data structure chapter. So what do you mean by stacks and what is heaps? So with the help of this concept, I can allocate the memory space by making use of this static allocation. So then how can I implement this dynamic allocation? So I can implement by making use of the data segments concept. I can use this dynamic allocation of a memory by making use of the data segments concept. So it's all about today's session. I hope you understood. In this session, we have learned what are the difference between dynamic allocation of memory as well as the static allocation of memory. If it is static, what will be the method that I have to follow in order to allocate the memory? If it is dynamic, at that time I have to take two variables or two operators, that is new operator as well as the delete operator. So in this, you have to remember its syntax in order to allocate the memory space dynamically and to deallocate the memory space dynamically. After that, I have discussed how can I use a pointers as a function parameter or as an argument. It's all about today's session. By the next session, I'm going to continue with the same chapter. Until that, keep learning, keep on growing. Thank you very much.